This is the gas collection over water tutorial. So if we have the reaction, hydrochloric acid with solid zinc, producing hydrogen gas and zinc chloride solution, we might be asked some questions about it. They'll give you some temperature and atmospheric pressure information. They'll give you the vapor pressure of water for that temperature, and they'll give you the volume of gas collected. They might ask a bunch of different questions like partial pressure of the hydrogen collected, moles of hydrogen formed, mass of zinc reacted, water molecules found above the mixture, mole fractions, kinetic energies, and velocities of the different gases. So what we're talking about is collecting gas by displacement over water. So we'll have a reaction vessel with our solid zinc and our hydrochloric acid mixture. The solid zinc will react with the hydrochloric acid, creating bubbles. Those bubbles will be forced through the tube into here. And this will be originally filled completely with water so that as the gas bubbles up, the water is pushed out. In order to do the reaction, in order to actually use the information and the gas collected volume along with the atmospheric pressure, we would actually take this vessel at the end and make sure that the water level on the outside was at the same height as the water level on the inside. That would tell us that the pressure on the inside of the gases here would be equal to the atmospheric pressure on the outside. So if we want to find out just the partial pressure of the hydrogen and the moles of hydrogen gas collected, partial pressure of the hydrogen will be given by taking the atmospheric pressure, which is my total pressure, subtracting the vapor pressure of the water, which is the partial pressure of the water, and my partial pressure of my hydrogen would then be 779 torr. I then use that as my P in PivNert to get my moles of H2. So my pressure is 779 torr. My volume is the 0.35 liters. My N is what I'm looking for. I use the value of R that has torr in it, and I convert my temperature to kelvins. Once I do that, right, this number is found on the reference sheet. How to convert from Celsius to Kelvin is on the reference sheet as well. Once I do that, I find out that we produced 0.0148 moles of H2. To then get the mass of zinc reacted, we're going to do a Stoic problem where we are going to take the moles of hydrogen produced and use the mole ratio. So if we look at the reaction, the moles of zinc has a coefficient of 1. The moles of hydrogen is a coefficient of 1. So it's a 1-to-1 ratio. So 1 mole of hydrogen in would be 1 mole of zinc out. In this case, 0.0148 moles of hydrogen in would be 1 mole of zinc out. So that's going to tell us that we make 0.0148 moles of hydrogen will give us, means that we reacted 0.0148 moles of zinc. We then multiply by the gram formula mass of zinc over 1 mole of zinc, which is 65.39 grams per mole. That would go here. 1 mole would go in the bottom, and our answer would be 0.969 grams of zinc had to react to give us that much hydrogen gas. If we want to find out how many molecules of water were found above the mixture, we now start back at the original information, and we are now going to go to the fact that it was 22 degrees Celsius and the vapor pressure of water was 21 torr, because the vapor pressure of water is the partial pressure of the water. We're going to use the vapor pressure of water in PivNert with all of our other information. Again, because this is in the vapor pressure was in torr, we use the 62.36 value from the reference table, convert our Celsius temperature to kelvins, use the same volume because the water vapor is in the same volume as the hydrogen gas, and we get 3.99539 times 10 to the minus 4 moles. If we wanted moles, we would make that 4.00 times 10 to the minus 4, but they want molecules, so then we multiply by Avogadro's number over 1 mole, and we get 2.41 times 10 to the 20th water molecules above the mixture. If we want to know the mole fractions of the water vapor and the hydrogen gas, we can do this in one of two ways. We can either use the numbers of moles and we can do moles of hydrogen over total moles and get the chi of 0.974, moles of water over the total and get the chi of 0.0263, or we can compare the partial pressure over the total pressure. And again, the partial pressure of hydrogen was 779, total pressure is the atmospheric pressure of 800, chi of water would be the 21, which would be the vapor pressure over the atmospheric pressure of 800. And the final part of the question, if we want to compare the average kinetic energies and the velocities, remember at the same temperature, average kinetic energies are the same. So the average kinetic energy of the hydrogen gas and the water vapor are identical. However, the speed or velocities would be different. The hydrogen gas molecules will move faster than the water molecules when they're at the same temperature because the hydrogen gas molecules are lighter than the water vapor molecules.